Good afternoon. This is Peter Smart. Welcome to our presentation this afternoon of Carlson Hydrology and extracting watershed data and moving that into HydroCAD. We're pleased that you could all join us, and with us today will be Gary Rosen with Carlson Software, who's going to be talking a lot about the data extraction capability. Before we get started, I just want to give you a little bit of background on using this go-to-training product that we're using here today. You can use either your telephone or your computer speakers in order to listen to the session, whichever works best for you. If you want to hang up the phone and just use your computer speakers, you can free up that landline if that's better for you. You'll probably not be using a microphone during the session, so just having speakers will work just fine for you. As you do have questions during the session, I would encourage you to use the chat box that's in your control panel. And you can open that up and just type in any questions that you may have as we go along, and we'll try to keep up with those and answer those comments as the session progresses. And so with that brief introduction, here is Gary Rosen, who's going to talk to us for a while about Carlson Hydrology. Good afternoon, Gary.
Hi, Peter. Thanks very much, and appreciate this very much, this invitation to share this forum with you. This is the second one that we've done featuring the Carlson connection here, and appreciate you doing that. And I know you're doing other sessions on other Tuesdays on other HydroCAD subjects that make sure we'll talk about before we're done so people know what's coming. But again, I appreciate this opportunity to show what we're doing here together with Carlson Hydrology and HydroCAD. And welcome everybody. It's great to see a good bunch of people signed up, and some names I recognize in there. Hi, Ken, and Brick I see, and Eileen. So some folks I know are on board, so thanks for taking the time. And everybody else, of course, welcome. And basically the focus for today's session is fairly narrow, which is good. Within Carlson Hydrology, I'm really just going to focus on this one piece of data extraction of the watersheds for HydroCAD. So there's lots of other stuff in Carlson that we can show. Show my screen here. You should be seeing my screen at this point.
Yeah, that's very good, Gary.
Okay, good. Thank you. But again, the focus is what we've been working on here for the last year and a half or so that we've been talking, and probably 6 months of very intensive work to put this thing together with a very specific purpose, which is to do this data extraction from your drawing. What I'm showing is Carlson Hydrology 2010. You do need the 2010 version, and you can get free demos of that, 30-day demos if you need to, and we can talk about that. The program sells for $1,000 list price. I'm running it currently, today, I'm running it on top of actually Civil 3D 2010. It can run on any AutoCAD platform, so that's AutoCAD, Map, Land Desktop, or Civil 3D from 2010 all the way back to 2000. So just whatever, that's about 40 platforms that it can actually run on. And the program itself actually ships with IntelliCAD as an alternative CAD engine if you don't have AutoCAD, or you just want to try a different engine. Again, it ships at the same price with the IntelliCAD included, so that's another option for you. So let me just jump right in and show you what we're doing, and let me kind of get through this fairly quickly, and we'll turn it over to Peter, and then we'll have time for questions and so on. So what you're looking at is just a sample that I put together, a relatively straightforward sample of a project. And what you're looking at right now is a combination of soil delineations, the HSG soil delineations, which is kind of the green with the letters. And I hope, does that look okay with the black background? Is it clear to?
That looks fine to me, Gary.
All right, good. Sometimes people say the white background shows up better, so we'll give this a try, but if anybody has a problem, let me know. The soil groups are shown, and I'll show you each one of these. The ground covers, the different ground covers are delineated with polylines. This is all just standard AutoCAD objects in the drawing. And we also, of course, have the watersheds or subcatchments delineated with the white lines, and those are labeled with the white labels there, 1S and 4R and so on. And we also have polylines, some polylines that designate the longest flow path, which the software is just basically grabbing the length of. Underneath it all, there is a surface. There's a tin developed by Carlson with the Carlson software, and that's all part of the hydrology software. I'm going to load up the hydrology menu. So with hydrology by itself, this is actually what the menu system looks like that you're going to get. So you've got all of your variety of filing and commands and drawing cleanup, all kinds of good stuff, and you've got all kinds of editing commands and all sorts of drawing commands and your settings. We work with points and surfaces. All of this is all part of the hydrology program, and those functions are actually all part of the civil program and the survey program as well. And then specific to hydrology is the watershed menu, which is where we do watershed analysis in this context. The structure menu, where you can actually build man-made and so on. The network menu, which is where you'll do your storm drain design, which again is not our focus for today, but this is where this would take place. And then in 2010 we have the HydroCAD menu, which is really all the commands you're mostly going to need to make this happen. So let's take a quick look at the drawing. I'm going to type the word view for the old AutoCAD View command. This is the newest version of the View command in AutoCAD 10, which is pretty sweet. It actually restores, other than just the zoom and the location like the View command used to, it actually restores your layers as well, which is pretty nice. So if I put in a view called soils and set it as current, you'll see that it takes me to this area but also isolates the layers. So nice AutoCAD command in there. But what you're seeing here is simple AutoCAD line work, polylines, with text for labels of the A, B, C, or D soil groups, hydrologic soil groups. Now these soil areas are delineated with line work on a specific layer, and I'm just going to take you very quickly to this main menu, which is called Define Watershed Layers. And what you would do when you first load this is you make sure you're on the HydroCAD method, and then you would come in here and load the HydroCAD.rcl file. It's the extension is RCL, which is Runoff Coefficient Library. You'll load that file and make sure that you set this back to HydroCAD after you do so. So you want to make sure you're in HydroCAD and these layers are set. And these are the layers that you'll use to do this whole function. This list right here, is the layers you will use for your ground covers. And you can change any of these layer names if you choose. You can just double click on one and change the layer name. What's hardwired in here is the description, and it's gray. You can't actually physically change it, and that's because we need those exact descriptions to coincide with the HydroCAD software. So you can't change those, but you can change the layer name if you don't like the ones that we put together. Down below is the rest of the layers you'll be working with is your soil layer, which here is I was talking about soil, so that's the soil layer that's used for line work. This is the layer that's used for the labels. This layer is for your subcatchments, and this layer is for your subcatchment numbers. And then down here I'm going to go ahead and set the layer called longest, is that what we used as longest flow paths? Subcat flow lines we used. Okay, so these, again, you can use any layers that you choose. You can make up names. You can use anything you want as long as you work, of course, on those layers to do this work. And then the only other thing really is your default ground cover, which, again, you can set from this list. You can pick whatever you want for your default. Let's go with, what should we use today? Let's go with just a half-acre lot, 25% impervious. So you set whatever you want for default, which is any area that's not defined specifically as one of these other ground covers. there's a button to create these layers, and it says the selected layers and the watershed layers and the soils layers. Created 5 layers, so you don't have to write them down and type them in again or whatever. You just create them right from here. And that's pretty much what you're going to do here is set this up initially. And again, you're going to start with that HydroCAD.rcl that'll get you started, and that kind of sets the stage. From here, you just have to get the right line work on the right layers. It's quite straightforward. The soils could come from anywhere. They could come from a drawing. They could come from a shape file. We actually, in the Watershed menu, we give you the import ESRI shape command from Carlson GIS. So you can actually, if your soils or your ground covers for that matter, or your watersheds for that matter, are coming from a shape file, you can import that shape file. Any way that you want to get this line work in here is fine. And the key is that these different areas are uniquely identified by line work. Now, this is a little confusing. Let me clarify this. I had a good conversation about a week ago with someone who's trying this out, and these do not have to be closed polylines. In my drawing, they happen to be, but they don't have to be for this to work. They just have to be uniquely defined areas. So this could be a separate polyline on the right side. This could be a separate polyline on the top. That'll work fine as long as you could essentially pick and be poly, as if you're familiar with the AutoCAD command, as long as you could pick in the interior and have the software able to define it, it will work. Now, the line work that defines these areas, though, must be on this layer. So someone had some of the line work on this layer, but they had some other line work on another layer. So the areas were defined, but they were not defined with line work that was all on this layer, and it wasn't working. And so that's what we had to sort through, and then it worked just fine. So all of your line work needs to be on this layer, whatever you chose in your list there, but it does not have to be closed polylines to function correctly. And then, of course, your labels are just pieces of text, capital A, B, C, or D, and that's how you basically lay out your soils, okay? If we move ahead and we look at your ground covers, these are, now what happened? This happened last time. Oh, boy. Hold on 1 second, please. Oh, it's funny that it did not thaw those layers correctly, as it should. No. Let me see what's going on here. Ground covers set current. Zoom extents. No. All right, here's what we're going to do is we're going to select all the layers and thaw them. It's funny, I just checked this right before we came online, and everything worked fine, of course. So I'm going to work backwards here and freeze some other stuff. I apologize. The layer view is being finicky. I'm just going to do it manually for you. This is what I wanted to show you, is these are the ground covers defined on the specific layers that are in that list. So the key to this is they're not labeled, so you don't need to label these, but they do have to be closed polylines. So as opposed to the soils that do not, the ground covers do have to be closed polys. This was the second problem the person I was working with last week ran into, was he had these and they weren't working, and we discovered that they looked closed, but they actually, officially, if you were not. So we had to, do properties and pick it and use the close option to make sure that they were actually closed polylines, and then everything worked fine. So these are closed polylines on the layers specified. There's some paving and some roadway and some roofs and a grassed area over here. So they just have to be on the correct layers, okay? And then the last one, let's see if it works this time, is we'll go to our watersheds. Yeah, see, and that one's working fine, of course, so that's good. And here's our watersheds. I basically have 4 watersheds defined and labeled, and the longest flow paths drawn in. And Carlson has the ability to help you define these watersheds, which I could show a little bit later, or you can just draw them by hand, or however you're most comfortable defining the watersheds or the subcatchments. You can use whichever method you want. But basically, that's what you wind up with. There's also a surface in the background here. So if I go to my viewer and I say 3D surface viewer, and we go and grab this surface, e.g. existing condition, this is the surface or the tin, DTM, that's behind the scenes here. And what we're using it for is to calculate the average slope for each watershed. Okay, so there you go. That's pretty much the setup. If I say combo and set it current, you should see it all back together. So all the views are working except for that one. I don't know what happened. But anyway, there it is all combined. It's just a little hard to see. But that's what you're looking at. And what we want the software to do is to cut through all of these layers and produce all of the little sub areas with their specific soil types, their specific ground covers, which watershed they're part of, their average slope, and so on. So that's all done here. In HydroCAD, we go to what's called the HydroCAD Explorer, and we set up an HYN file, which is essentially a HydroCAD project file, but it's a kind of a special version of it that we're using. So I'll make a new one. We'll call it whatever you want. Let's call it what's today, 16, 17, 16, 2/16/10. We'll give it today's date, or whatever name you like, and it opens up this Explorer type of interface. If we look at the settings very quickly, we say that the surface file is in fact EG, and we're also going to say that we're using the curve number lag method, and we're not going to process curve numbers. We're going to let HydroCAD do that. We can change any of the subcatchments to TR55 if we choose after the fact, but we want to start them all out with this method. And the rainfall we're going to leave blank. We're going to put that in HydroCAD as well. So that's basically the general setup to process. And we're really ready to go at this point. We say update is this little up arrow, and it says what do you want to update? The sub areas, the time of concentration, the plan location, which kind of orients the symbols correctly, create any new subcatchments, which of course for us would be all of them at this moment, and we're going to go ahead and export it to HydroCAD as soon as it's updated. All these are options, but we're going to turn them all on. So we say go ahead and process this, and it says it created 4 subcatchments. Here they are listed here, and it starts up HydroCAD, and here they are in HydroCAD. And that's as simple as it gets. That's how it's done. Now, if I jump back over to Carlson for a moment, let me show you, for instance, 1S. If I double-click, you'll see that the area was calculated, the average slope was determined from the tin, the length of the longest flow path was put in from that polyline, and if we dig into the areas, you'll see that it's completely broken down, each sub-area by soil group, by description, and of course you'll see down here that the default was used for any areas that did not have specific ground covers. So all of this tedious work that you've been doing by hand is basically the problem that we attempted to solve, and I think we've solved in this release of Carlson working with HydroCAD. If we go back to HydroCAD itself, if I go to look at one of these, I'm going to get a message that there's no rainfall because, remember, I did not put a rainfall, although I could have, but I did not. So I'll say OK. I'll go to my settings, and I'll put in a rainfall, and I'm just going to put in 2 inches just so we have something. And if I now double-click, you'll see that, of course, there's the hydrograph. Here's the summary for that subcatchment. The hydrograph is set to curve number. It came up with a curve number, of 83. And we also have, I'll just minimize that for a second, and we can see the overall report for the whole site. The project report, here's the node listing, and here's the area listing for the whole site. You can check to make sure that nothing's missing. Here's your soils listing of each area and so on. Just beautiful information instantly generated. And if I close this and just do one more thing, and then Peter, I think I'll turn it over and let you take it from here. But if I come back and we had a bring this back up, we had a hydrograph with a curve number of 83 for 1S. So let's go back to Carlson. Here's 1S, and this is a paved area. So let's say that I change my mind, and unfortunately I've got to pave a bigger area. We need more parking. So in AutoCAD, I just grip the polyline and change the area. I'm doing it very simply, but you get the idea. You make a design change, and I just simply update, and I get a message that everything's been updated. In HydroCAD, I get a message that it's ready to merge the new information, and we were at 83, and now we're at 87. So the model is instantly updated. One last thing to point out is what Peter has put in here is under Settings is a Merge menu that tells you what to merge. And you'll see that the rainfall is shut off because, again, I'm not sending rainfall, so if that was not shut off, it would set it back to 0. So I wanted to say, don't mess with the rainfall, but go ahead and update the rest of the information, which is exactly what it did. And that's really the crux of it. We can also work with ponds and reaches and links. We're not going to cover those today, but maybe in a subsequent webinar, Peter, we could look at those. But for today, that's the focus. And I think I'll turn it over to you so you can show some HydroCAD, and then we'll see if we have some questions.
Okay, great. Thank you very much, Gary. I think it's worth commenting on this issue of calculating the time of concentration, because you've mentioned the calculation of the average slope in your presentation. And what we've done here is you have an option of using either the traditional TR55 approach, where you have a segment of sheet flow, then shallow concentrated flow and channel flow, or you can use the curve number or lag method. The advantage of the curve number lag method in this environment is that Carlson Hydrology can automatically calculate the average watershed slope as well as the length of the maximum flow path. So with those input parameters and your curve number, we can automatically determine a time of concentration. One of the advantages of the curve number method is its objectivity, that it's not dependent on your judgment as to how much distance of sheet flow you have at the head of each watershed. And as I'm sure you know, that's a primary issue in determining your time of concentration. There can be very reasonable disagreement as to how long that sheet flow should be. Is it 50 feet, 100 feet, 200 feet? And that's an issue that reviewers are just struggling with on a constant basis. So the curve number method, we're seeing a resurgence of interest in using this procedure because it does give you the objectivity of how you calculate that time of concentration. But again, you have the option as to which way you want to do that. It's just that we're giving you this technique which can give you that objectivity and consistency in results. So I think that's worth mention.
Yeah, absolutely. Did you want me to show one of these?
Yeah, please.
Okay, so if I open up, let's say 1S, right here it says the method is curve number lag, and if you would prefer TR55 for any particular subcatchment, you can do it right here, and you can say, okay, change the method. You'll notice that the average slope and the length disappears, and when I go into TC and edit, you get the Carlson time of concentration TR55 method, and you would add, and you'd say I want to add a sheet flow or a shallow flow or a channel flow or a combo, and you would proceed from here. If I want to put in a sheet flow, I'll put in I'll get to this screen. If I have a polyline, I can pick it off the screen. If it's a 3D polyline, it'll measure the slope of it and it'll plug it in, and I basically can put in any of those elements and just stack them up or use the combo method or whatever and just switch any particular subcatchment to TR55.
So the goal here is to give you full flexibility. We recognize that no two sites are the same, and everyone has different approaches to how they model their site, so we're giving you that full control. Also, I want to comment that the way you've delineated all of these layers is leaves you full discretion. Although Carlson Hydrology has a capability to automatically delineate subcatchments and draw those lines for you, that's going to be subject to the accuracy of your survey and your terrain model, so we know that you're often going to have to tweak those boundaries, and you're perfectly free to do that. Or perhaps you're even going to just draw them in by hand on top of your survey plan. You can get the data any way you choose. We're not locking you in here. We're just giving you the flexibility of adding additional tools for data extraction.
Yeah, very, very key. Very key. And I could take 1 second here, Peter, and show a watershed analysis, and I could say for this surface, and I'll get this dialog to pop up, and I'll basically just say, show me the watersheds, fill them, and show me the sinks and the maximum flow lines. Turn any of these off and on however you want. But if I just quickly draw this surface in, this is Carlson using the tin to try and determine the watersheds and delineate the watersheds. And exactly as you said, if the hydrologist does not agree, they can combine them, they can redraw over them, however they want to do it. But we do offer this tool working off of a tin to help with the process. We can draw arrows to help you, or any way that this might help you, or you can bypass this completely and say, you know, no thanks, I'm just going to draw them in by hand. So any way you want to get this geometry, these entities drawn on the soils, ground cover, and watershed layers, any of those three, any method you have to get those in will work. All we're looking for is simple AutoCAD geometry on the specified layers. Thanks.
Yeah, that's great. Thank you, Gary. I'm going to go over to HydroCAD for a little while now and talk about some of the related features there. If you've got any questions, again, just use the chat box in your control panel and type in any questions or comments you may have, and we will try to get to those and discuss any details that you might want to know a little bit more about.
Should I change?
Yes.
Should I make? Okay, sorry.
No, that's quite all right.
Here you are. And you should.
Very good. So you should
There
see.
you go.
Okay, here's my HydroCAD
Excellent.
screen. So I'm just going to bring up the Mountain View Complex project. This is a demonstration project that you've got pre-installed on your HydroCAD systems, of course. And one of the reports that's really worth looking at is the project report button. You're all used to looking at individual node reports. You just double-click a node, and of course you get a full report window for that particular node. But the project-wide reports are up on this project report icon. And this is very handy in the context of the Carlson watershed data extraction, because you have tabs here for your soil listing, for one, which shows the amount of soil we have in each soil group. And then it shows which subcatchments contribute to that particular group. It's very useful to look at this report and make sure you don't have anything in other here. This guarantees that your entire site is included in one of the mapped soil groups. It's also useful to note, just a comment, that when you're setting up a subcatchment that has an impervious surface, a pavement, driveway, parking lot, you are still classifying it with a soil group. And the reason for that is basically to make sure that your area of each group of soils remains the same in your existing and your proposed condition. Even though it's covered in an impervious surface and the soil group does not any longer affect the runoff, we still find that many reviewers are looking at this just to make sure there's a consistency in existing and proposed conditions. And of course, it's much easier now for you to maintain that consistency if you're extracting the data from a CAD model. Then it's, as long as you set up the layers properly and you're using the same soil groups pre and post, then your numbers are guaranteed to match up. You can also look at the area listing report, which will show you a breakdown of the individual ground covers that are being used. And this would show you, for example, that when you do have an impervious surface, and we don't have any in this example, but if you had an impervious surface, it will still show you the soil group that applies to that. And then there are a bunch of other reports that are available. There's new reporting now available for land use, and this corresponds to pollutant loading calculations, which can be performed using the simple method or other procedures. If you're interested in looking at that at any time, you can go to Settings, Land Use, or you can just go to the corresponding icon, which is over here, the little house. And on Land Use Settings, you can just check the box and indicate that you want to do land use reporting for that project. Or you can go another level and you can do full pollutant loading calculations. And you can define not only the land uses that you want to use for that particular project, but you can also define each of the pollutants and the concentration of each pollutant for each land use. And then with all of that information, the reports will now have an additional component which will show you that pollutant loading. So in here it shows the land use that corresponds to each of these. Because of the method I've selected to calculate the pollutant loading, we need to go into this project-wide report, and here we can see for each subcatchment the total weight of suspended solids, phosphorus, and nitrogen on a subcatchment by subcatchment basis with the total for the entire project. And there are several reports that show this breakdown in different ways. This is showing the loading for each land use, and of course you can look at each of the pollutants that you've defined and their concentration for each land use. So just to make you aware that this capability is available now, this was added in HydroCAD 9.0, and we're seeing more and more states are starting to require pollutant analysis calculations, particularly on larger sites. And in future releases, you can expect to start to see pollutant removal calculations as well being incorporated into HydroCAD, and it will basically route those pollutant loads down through the system. So you'll be able to see them propagate and look at what the total loads are at the bottom of the drainage system. Another handy capability that's been added in 9.1, just to touch on briefly, if you're setting your rainfall events for a particular project, I'm sure you know you can set each of those events here and type in a name. You can also use the import button in order to import rainfalls from another project. But the new feature is the lookup button. And the lookup button takes you to a lookup table. And you can just come down this table to your particular state and county, pick that line, and this has the information on which rainfall distribution is used for that location, as well as the depth for each of the storms. And we just click OK, and all that information is brought back into the project for us. That lookup uses the standard NRCS lookup table as used in TR55 and TR20. You may have noticed that a lot of areas of that, such as Alaska, are blank. NRCS has not compiled information for certain areas. But you can create a custom table if you want to, and then you'll be able to select that custom table down at the bottom of the screen. So here I've got a custom table which I've just limited to Massachusetts, for example, or New England. So you can remove areas that you're not concerned with and even customize this and put in different depths as may be appropriate depending on the rainfall sources that your particular regulations want you to use. And then one other item worth touching on is the capability to model arch and elliptical pipes. This is available anywhere there's a pipe in HydroCAD. This can be a TC flow segment, a reach, or a culvert outlet on a pond. And when we come to a culvert outlet, you can do a circular, a round culvert, and you get an illustration now of what that profile looks like. Or we could go to a box culvert where we could set a width and a height for that box culvert. Or we can use an ellipse or an arch pipe. With an elliptical pipe, we would set the width and the height, and then we have to specify a top and bottom radius, and this will vary depending on the exact construction of the pipe. So what you should do is go to your table book for the particular pipe you're using, and depending on whether it's steel, concrete, and they will have different parameters there. You can fill in a top radius, which is the same as the bottom radius for an elliptical pipe. And you can see how that shape varies as we increase or decrease that top radius. You can also do an arch pipe in a very similar manner, and you need to put in a top and a bottom radius in the case of an arch pipe. And if we decrease that top radius, then you'll see a more typical arch shape developing with a much larger radius at the bottom. And then finally, you can have fill in any kind of pipe. And this is increasingly common where a pipe is being partially buried in order to maintain a natural stream bottom. And so now you could just set that depth of fill for the culvert, and this works with any of these culvert shapes. And now the profile is automatically reduced with a flat bottom. So just to make you aware that those capabilities are there in the new 9.1 release. Are there any questions at this point? Anything concerning Carlson Hydrology is really what we wanted to focus on. Again, these capabilities are added in Carlson Hydrology 2010 and in HydroCAD 9.1. The previous 9.0 release does not have the Carlson import capability, so you do need to upgrade to 9.1 in order to be able to do this.
Now, a couple things on that note is when we do have a 30-day demo of Carlson Hydrology 2010 that you can get from us. Go to hydrocad.net. You can get it from there, or contact me or Peter. We can give some contact info. But the main thing is you can download that, install it on your AutoCAD or on the IntelliCAD, and what it will do is it will install, when you install Carlson Hydrology, it will look to see if you have HydroCAD on your system, and if you do not, it will install a demo of HydroCAD as well. And if you do have HydroCAD, but you want to try the 9.1, what's the best way for them to go about that, Peter?
Well, first of all, we have a link. If you look at the materials section of your control panel, I've added a link to Carlson Hydrology and HydroCAD, and that will give you links to the demo and various other material. If you were asking if they've already got Carlson Hydrology but an older version of HydroCAD, then the best thing is...
Well, yeah, or if they have an older version of HydroCAD, so they're HydroCAD users, but
right.
It's not 9.1, and they get the Carlson demo, how can they, what's the best way, I think I know the answer, but you go ahead with the best way for them to get the 9.1 demo.
Probably the easiest thing for them to do is to put a HydroCAD sampler on that system. That will replace the current HydroCAD installation, and then they would simply reinstall HydroCAD when they're done. Or, of course, if you have another machine that you do not have HydroCAD on, then you could just install it there. But the installation is very simple. You don't have to uninstall. You can just install one version over another, and it's very clean.
Okay, just to clarify that. So, and if anybody's doing that, has any issues, please get in touch with us to help you through any issues you have there, so you can give this a try with your own data sets. I've been talking to a number of people that are running their own data through this, Peter, and really having some good results. The guy last week, we sorted out those two really important issues. One was, again, that he had the soils areas delineated, but not all the line work was on that correct layer. So he said, well, the areas are defined, but the software only looks at the geometry on that one layer, so all the line work had to be there. And then we discovered a ground cover polyline that looked closed but wasn't. And once we solved those two issues, it just worked like a charm. So
okay, good.
I'd love to have everybody give this a try. What else? Are we missing anything else? Oh, I know what I was asking. If you could show a little bit is the underground storage.
Yes, certainly. And before I do that, we did have one question, which was concerning the curve number and lag method. And the question was, if your longest flow path starts with sheet flow and ends in a full stream, can you still use the curve number lag method? Basically, the curve number lag method is intended for areas where you don't have detailed enough information to determine exact flow regimes. It generally is not mixed with other procedures. So if you had an area that was coming down to a stream and you wanted to model that stream separately, perhaps as a reach, then you should probably end your curve number, your TC calculation, rather, at the point you come into the stream. Usually they're not mixed together. The curve number method is used instead of other procedures, and it's designed to incorporate all of the different flow regimes. One of the interesting things about the curve number method when you look at it is that it's using the length of the flow path, but the slope that it's using is the average over the entire subcatchment. So it's sensitive to changes in slope anywhere in the system, as opposed to just looking at the slope along the flow path and ignoring the slope of the rest of the subcatchment. Yeah, and we had another question here. A couple of questions, actually. Is there a size of project where use of Carlson HydroCAD makes sense, or does the system make more sense for 1 or 2 acre sites? I think it's entirely a matter of the time it will save you extracting the data. What we see is that getting the subcatchment areas broken down is more than 90% of the data that has to be entered into a given HydroCAD model. And certainly if you've already got these layers set up in AutoCAD, whatever platform you may be using, there's going to be a big savings to you in extracting that information. Perhaps in some cases you've just got a few sub-areas and you know what those numbers are, but the question still is, how do you know what the numbers are? You're presumably measuring them off a drawing somehow. So I still think this is going to save you time, whether it be a very simple or a very complex project. And certainly what you should do is try it out with the demo and see how it works.
Yeah, absolutely. I think one of the things that we're excited about along those lines is that it is applicable for really any size project. You know, there isn't, the small projects are not ruled out by any means, nor are the larger ones. So, you agree with that, Peter?
Yes, definitely. Yeah, I think you should try it. Particularly once you've learned to use it, I think you're going to find it's very fast and intuitive.
Good.
Now we had another question. Yeah,
I saw this question from Brick about the HydroCAD Explorer did not see the settings icon to the right of the rainfall event.
Yes.
And I believe what you really need to do, I think the first thing I'd recommend is go to the Carlson website and download, make sure you've got the latest build, because that was a change that was made. I don't remember exactly when, but I think that settings button was moved up after we asked Dave to put it in a more prominent position. So the original shipping version may not have it up there, but the latest builds should. Now, Carlson should be checking for builds, but if you have not downloaded a recent build, that may be something that you want to do. And it is down below in the version, whatever version you have, it is down below. My concern is if you're not seeing it up next to the rainfall, then you probably, again, don't have the latest build, and there may be some other things that were either corrected or enhanced or whatever. So again, I would strongly urge you to just go get that latest build and make sure that you have that. And I believe that's going to be the difference.
And Brick has said he did find it down below, so you were right about that.
Right. Definitely still go check for a new build, though, Brick. And again, I can help you with that afterwards. If you need help, just let me know. Speaking of which, I guess let me, my email address, it's Gary Rosen, and my email is grosen, GROSEN, at Carlson SW, CARLSON SW, like software.com. So if anybody has any follow-up questions, or you want to do a private go-to-meeting and look at your data, or anything I can do to help and encourage you to try this on your own, please let me know.
Good. And again, just a reminder, if you go to the materials section of your control panel, you'll find a link there which brings you to our page on HydroCAD and Carlson Hydrology. And we have a previous recorded webinar there. So if you have someone else who's interested in this material, then you can point them to that. And there's also a shorter 10-minute version. And there's more detail here, discussion of exactly what the process is for setting up these different layers with illustrations. So you can go through and have a look at that.
That's awesome.
Good. Do we have any other questions or comments at this point? We do have other programs coming up. I just want to point out this is one of a series of new bi-weekly free webinars that we're running. They are at 1 o'clock on alternate Tuesday afternoons, and you'll find a full list of those on the HydroCAD.net website. If you go to support and then training, you'll find a link for webinars. And we have programs coming up discussing new HydroCAD features, such as underground storage, for example, which Gary was suggesting that I show you just briefly. Our new storage wizard is a really cool tool to use. If you go into your sample HydroCAD projects, for example, that are, again, pre-installed with the software, you'll find a project that shows you a side-by-side comparison. The pond on the left is set up using underground storage, but with the storage manually defined. So when you go to the Storage tab, the engineer in this case has set up their outer field of stone, perhaps as a prismatoid, and then they've defined their chambers and specified that those chambers are embedded inside the stone. And this procedure continues to be there. It works just great, but it leaves you with the layout issue of having to work out how large the chambers are, how much space you need between the stones, how much space between the chambers, under them and above them, in order to work out the total field dimensions. So instead, with the Chamber Wizard, you can simply create your pond, edit that pond, and indicate that it's a detention pond. And then when you define your storage, you would pick the Chamber Wizard. And on the Chamber Wizard screen, we can now select the chamber that we want to use in that particular screen. So this is an ever-increasing library of chambers. We've just added Eco Chamber a couple of weeks ago. There are a lot of different manufacturers just increasing almost daily. So you pick the particular chamber you want, and then you can specify the number of rows of chambers and the number of chambers per row. And of course, with most of these prefab arch chambers, you have to have a certain amount of stone between them and around them, and you can simply set that spacing between the rows and next to the chambers, the stone cover, or you can just check the box to use the typical spacing, and it brings up all of the manufacturer's defaults for those layouts. So now as you set the number of chambers, you get automatic layout of the field and a complete analysis here of what that field looks like, the total storage, and you can even estimate the costs here. You can put in your chamber and excavation and stone costs, even additional materials, so you can create a little bill of materials report here. And this is very powerful for comparing different kinds of chambers. Perhaps you're comparing a concrete vault to a plastic arch, and so now you can price those two out. And there's a price list feature here that automatically records the price that you've used for each of the chambers. So as you switch from one to another, it remembers that pricing. And then once we click OK on this entire description, the wizard has automatically created the two storage definitions that we would have gotten if we'd done this by hand. It gives us the outer field of stone, and then it gives us the chambers embedded in that. And so now looking at our storage tab, we have the stone underneath the chambers with, in this example, 40% voids, and then a faster increase in the amount of storage because of the space in the chamber, and then finally slowing as we get to the stone cover. So same kind of results you got before, but a much, much faster process to get there. So I just think that's worth mentioning. That was added in 9.0, the Chamber Wizard. If you haven't had a chance to look at it, that's a great thing to use. I noticed in our sign-up list that we have all but just a couple of people who are not using HydroCAD attending this session. Everyone else is. And I think about a third of our attendees are using Carlson Hydrology. So hopefully more of those folks are going to have a chance to look at Carlson after this session.
Yeah, please do. Get in touch with any questions. And those of you using HydroCAD, give this a try. We really targeted initially, the people that are HydroCAD such devout fans, just to provide a tool to make this part of the process easier. But we're just, Carlson Software is just so excited to have this partnership with HydroCAD, with the expertise that HydroCAD and Peter bring to the profession. For us to have this partnership is really just the best of both worlds, and we just this is our first go with this new idea, and we're going to solicit feedback and just improve it continually from here. But we think we've got something really good initially as well. So please give it a try, and please let us know what you like, what you don't like, if it works, if it doesn't, if it seems like it'll save you time, or if it doesn't. Any feedback is greatly appreciated, so we can just continue to make it better.
Okay, great. Well, thank you very much, Gary. I don't see any other questions at the moment, so I think perhaps we'll wrap it up for today. Do remember that we've got other sessions coming up in 2 weeks. We have new HydroCAD features in detail, which will talk about land use reporting and pollutant loading, and then we have a session after that, which will get into underground storage modeling in more detail. And then there's a general program on getting started with HydroCAD if you've got new folks in your office who haven't used it before. And then we're going to do an overview of new features, which is a very packed program that will attempt to cover the couple of dozen new features that have been added in 9.0 and 9.1, just to make sure you're aware of those. So again,
I'll be watching those, Peter.
Okay, cool, Gary. And Gary, thank you very much for joining us, and thank you, everyone. Have a good day.
Thank you.
Bye-bye.